last time we left off with a practice problem. Was anybody able to give it a shot and think they had the solution? You can just say so in the chat if you did. If not, I will go over the solution really quickly. So it said, to make a speeding ticket program that took 2 inputs. Sorry, it takes 2 inputs, the speed and the speed limit, and it'll determine what their fine is if they were speeding, and it prints out the fine as a message. So every $10 over the limit was a fine, or it was for every kilometer over the limit is $10 fine. So the solution to that would have been file actually. That is P1. Okay. So you can have it open on your computer. I'll just put on my other monitor. Okay. So essentially you want to take the input, right? So we're gonna have speed equals input. What was your speed? Just limit input. What was the speed limit? So obviously we need both of those numbers. And so you want to see how much the speed was over the limit. So I want to do to get every kilometer per hour over the limit, we do speed minus limit. We want to start that in variable, right? So let's say over speed, I guess you could say, equals speed minus limit. And then we want to say, obviously we try to print over speed. The message was supposed to be your fine is whatever amount. Your fine, whoops, this has to be in a string. So it would be your fine is $, and then comma overspeed, and it's not just overspeed, it would be the fine, sorry, the fine would be overspeed times 10. And so fine. If we try to put this, if we put an input, for example, let's say their speed was 10, or no, not 10. Let's say they were speeding like 50 in a 20 zone, it would be 30 times 10, which is $300. Oh yeah, this is the first issue with the tip that I gave. So whenever you take an input, the value is always a string. And the issue with that is whenever we try to do speed minus limit, it's a string minus a string, and we cannot do string minus string. We can only do addition, multiplication. Those are the only operators we can do. So the way to fix this is we can convert these values to an integer using the int function. And quite simply, it just converts whatever's inside of it to an integer. And now, if we convert, let's say if we entered 50 for speed as a string, let's say this was a 50, this would be evaluated to an integer 50. So there's that. Now this should work because we're doing operation with integers. Your speed was 50, you're going in a 20 zone, your fine is 300 because you're going 30 over times 10 is 300. The issue with this is that, let's say, for example, you weren't speeding. Let's try to run this. Let's say your speed was 10, and let's say you're going really slow, so it's 10, and let's say the speed limit was at 20. It says your fine is negative 100. Now, this doesn't make any sense, right? You're not going to get paid $100 by the police if you're going slow. Actually, if anything, you'd probably get fined, but we're going to ignore that. In this case, what we're going to do is we're going to set the fine as we're going to set the max value of the fine using, or sorry, we're going to set the minimum value of the fine using the max function. It sounds weird, but it'll make sense in a minute. So the max function takes two parameters. They're both integers, x and y, and it just returns the largest of the two values. So if y is larger than x, then fine would be equal to y. In this case, what we want to do is we want to set one value to 0, and then we want to set one value to fine. And this makes sense because, let's say, for example, overspeed was negative, and times 10, fine would also be negative. And so fine would be a negative number, and it would choose 0. So your fine would end up being 0 if fine was a negative number. So it can't get less than 0. So we put their speed was 10, then it was 20, your fine would be $0. That is one solution to this problem. There are other solutions, obviously. With programming, there's generally not only one solution to the same problem. But moving on to the actual lesson, the actual workshop. Okay, I'm gonna open the file. Save this as W2. Go. So, okay. So the first thing actually isn't actually going to be code, but it's going to be documentation. So when we were coding, there's a bunch of functions. We use input, we use int, we use max, and you don't want to have to memorize all these functions because having to memorize these functions would make coding very inefficient. Programmers don't actually memorize. What they do is all of these functions are available by the person who created them in an online document, and that is known as documentation. So essentially, you can find all the functions that we used that come pre-installed with Python. It's like print, int, and max, min, and a bunch of other functions. You can find it in the Python documentation, which is this site here, Python docs. So you can pretty much find a ton of functions here that you can use. A lot of them come pre-installed with Python. You can see here. You can, let's say you want to find max, right? Yeah, so max appears here. It tells you, is this the one we used? Yeah, I think this is the one we used. Yeah. arg1, arg2. Yeah, so we used the arg1, arg2 version. Didn't specify the second one. If there are two keyword-only arguments, the key is the right one. I think this is the right one. I believe. Yeah. Let's look at an easier one actually. Int. Yeah, so you can pretty much just find these functions online through the documents. It becomes more obvious when you're using external libraries because these are a bit these are really in depth. Essentially, this just these are the descriptions. It tells you what parameters they take in, etc. You could also just Google it, but most of them are found here. And you can, if you want functions that don't come pre-installed with Python, you can import what is known as a library, which is external functions. But we'll talk about that later in the lesson. Okay. Yeah, we'll talk about that later in the lesson. That's pretty much documentation. If you want to find more functions that are useful, there's a ton of them. There's, for example, there's length. You can, you see if length is a good one. Okay, yeah, okay, this one's a good one. It tells you this, it's not too thorough. It just returns the length of an object. In this case, if we try to do len string, let me close this. Okay, so if we try to do print len some string cats, say, it should print 4 because the length of the string is 4, and it's a pretty useful function, but you might not always remember it, and that's when you use docs. So yeah, that's documentation, and we're gonna move on to one of the other main one of the other most useful tools in programming, and that is if statements. So if statements essentially take a condition and will run a section of code if the condition is met. So I'm just conditions are booleans. So I'm just going to put a direct boolean here. Usually it's not you don't put a direct boolean here, because then this will always either run all the time or never run. You want to set the condition usually related to a variable, but I'll just leave it for true for now to put out the format. You put if true, and then I guess print whatever your code goes. Your code goes inside the if statement. Then after, if we do print hello, bye. So you can see that if I run this, this condition is met, so it prints bye, and then it prints hello after. So, and then if I set this to false, this condition is not met, and then it won't run this code. So if I run this, it should only print hello and not bye. Right, so it skipped over the code on this line because the condition of the if statement was not met. So it didn't run. So yeah, that's the gist of an if statement. I'm going to show a better example. Let's say you, going back to the like the height requirement problem that we did before. We didn't use the if statement there, but we used it to create a Boolean expression. So let's take an input of a height. Or sorry, height equals input. What is your height? And then we also want to convert this to an integer. So I'm just going to wrap that with int. So what this is this might seem a bit weird, but you can actually wrap a function with a function. So what this is a string. What I've highlighted is a string, right? It's the string input, and it's going to be a number. And then let's say we input 20. It's going to be 20 as a string, and then we're going to convert that 20 as a string to an integer. And now height is an integer that we can use to do operations with. And so we're going to do height, and then we're going to do requirement equals int input what is requirement, and then wrap that. And now our condition is going to be a Boolean expression using variables, and it's going to be if we want to say that you are tall enough to ride. Otherwise, and sorry, yeah, you want this expression to print you're tall enough to ride based on these two variables, and we want to say that they're tall enough if their height is greater than or equal to the requirement. I believe I spelled it right. Let's see. Yeah, okay. Yeah, so let's do that. What is your height? Let's say you're 20. Let's say the requirement is 10. It should say you're tall enough to ride. The issue with this is that, for example, if we run this again, whoops. If we ran this again, say your height is, actually, if your height is, say 20, requirement is 30, say you're too short, then nothing happens. And you probably wanted to say something when you're too short. Probably wanted to say that you're not tall enough to ride. Okay, so you want this to happen. You don't always want this to print, right? And it will, because right now it always will, because it's not an if statement. You want it to run conditionally. So we're going to put in an if statement and do if. And what's our condition? Our condition is going to be if height is less than or equal to requirement, or no, not equal to, if they're less than the requirement. Because if you set it to equals to and they are the exact requirement height, then it would print both they are tall enough and they're not tall enough, even though, and that doesn't make any sense. You only want one thing to happen. So you want to cover the edge case there. So you would just do less than requirement, then they're not tall enough to write. So if we print this, height 20, requirement's 30, now prints that they're not tall enough to write. Now this is a fine, this is fine. This is a fine solution to cover both cases, but there is another element to if statements that you can do to make this a bit easier to code, and that is Elif statements or else if statements. You can have it so that you can also have else statements as well. I'll cover that first. Else statements only run if the previous if statement or statements have not been met. So notice how you're not allowed to put conditions for else statements because the condition is just the absence of the failure of the previous conditions. So notice that if I do this, it should still have the exact same function. What is your height? 20, requirements 30. If you're too short, the first if statement failed because this isn't true. Height is not greater than requirement. It is actually less than. So this failed, and so this ran. Now the else if statement, I'm just gonna remove this equal sign just to make this make sense. The else if statement, it combines the if statement and the else statement, where if it'll only check this condition if this fails. Yeah, pretty much it's like an if statement because it has a condition. So I'm gonna do height is equal to equals is the comparator is the equality comparator. And I'm gonna do print you are exactly tall enough to ride this. So be consistent. You're exactly tall enough to ride. So this will only run if this will only check this condition and run this if this fails. So the failure thing is like the else statement and the condition part is like an if statement. So it's like a combination of the two. So you click run, say their height is exactly the requirement. It ran this print statement, as you can see. Oops. It ran, so it ran, Yeah. Okay. So you can see that it ran this print statement. And so because this Elif statement was successful, this else statement did not run. Because as we said before, this else statement would only run if the previous if statements all failed. That is not the case because this was successful. So yeah, that is if statements. And so that's how you get your code to make quote unquote decisions based on input, which is really important because you want your code to be reactive. Most programs are reactive, except for, I guess you could say, like bashing algorithms that take. I mean, some bashing algorithms require input, if statements, but if it's just usually you'd want your code to react to something. Should probably leave this. Okay, and so. Okay, so now that we covered if statements, we're going to cover the next thing, which is loops. And one useful thing about one of the strongest like aspects of programs is that they can do repetitive tasks very simply, and that's why like a lot of stuff nowadays, a lot of repetitive tasks like I guess like Excel spreadsheets. Maybe if you want to format, maybe like copying data from one place, one like a PDF, for example, to an Excel spreadsheet, or I guess from yeah, let's say you can't copy paste it, for example, because you didn't scan it properly. Instead of having to type it on yourself, you can have your code read the uh, the image of the PDF, and it can do that task repetitively instead of someone doing it by hand. So yeah, enough of the applications. We're gonna go into implementations of loops. So there are two different types of loops. There are while loops, and there are for loops. So we're going to cover while loops first because they're the simplest. While loops take a condition. So we're going to put true just as a placeholder. Print hello. So while loops run indefinitely until their condition is not met. So obviously, if you don't want this to run forever, you need to put a condition here that runs based on a variable. So in this case, we're going to set a variable named x. We're going to set it to actually, we're going to set this outside here. We're going to set initial value for x, let's say 10. And then we're going to do x equals x minus 1. So I'm going to print x here. So an explanation for this is that x, okay, this line of code will decrease x by 1 every time it runs. So, and the reason being is because you set the value of x to whatever x minus 1 is. Quite simply how it is. So for example, x is 10. On the first run, x will become 9, and then we'll print x. Actually, if I want to print 10, so I'm going to put this up here first. So first it's going to print the 10, then x is going to take the value of 10 minus 1, so x is going to become 9, and then it's going to print 9, then x is going to be 9 minus 1, which is 8, so then it's going to print 8, and it's going to become 7, and it's going to print 7, become 6, and then dot, dot, dot. Now this is going to happen forever. If I try to run this, you can see it's, well, that was pretty fast. Now it's constantly decreasing forever. I think we'll have, actually no, probably no error will occur, except for maybe memory. Besides that, we want this, let's say we wanted to count this down from 10 to 0. In order for that to happen, you want this to stop decreasing once x is equal to 0. So you want to do while, while, we're going to make a condition while x is not equal to 0. Oh yeah, I didn't cover this in an example in the previous workshop, but in order to check non-equality or inequality, you use exclamation mark and then an equal sign. So this would evaluate to true if x is anything but 0. So this will run so long as x is not 0. So if we try to run this, we know that x would be 10, then 9, then 8, then 7, dot, 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 3, 2, 1, and then once it's run, it'll print 1, decrease by 1, and then it'll be 0, so then it won't print. So it should print numbers 1 to 10 inclusive. So do that, you can see that's how it is, and then it stops. The while loop stops, the program ends. Yeah, that's while loops, they run off a condition similar to if statements. Pretty much just an if statement that runs repeatedly, I guess. Instead of exiting the if statement, it does it again. Yeah, and this could also, a better practice to do this is to do so long as x is greater than 0. Because let's say, for example, we incremented this by 2. This would not work because, well, it would work, but let's say x was an odd number, 11. If we do not equals, it would skip over the 0 and it would run indefinitely. So you generally don't want your if statement to be a negation of one case, but rather a succession of a singular one or a group of cases. So in this case, let's do a group of cases greater than 0. So long as it's greater than 0. This is better programming etiquette for the case we're doing. In this case, we start at 11, decrease by 2 each time. And so, yeah, we decrease by 2 each time. And once it went from 1, and then 1 minus 2 is -1. And then this condition was failed, so it stopped. Okay, so that's a while loop. Now we're going on to a for loop. So, okay, so for loops are a bit more different, but essentially they run for I guess you could say a specific amount of time that you specify at the beginning. Whereas while loops run conditionally, for loops run a certain amount of times that you set at the beginning, which has its own uses. And the way you do it is you would use, say print. Hello. Okay, so this is the basic for loop that would run 10 times. The way you do it is for I in range 10. The range just means run 10 times. We'll get into the I in a minute, but for now, we're going to try to print this. This loop should run 10 times. That's what range 10 means. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So yeah, this loop ran 10 times. Now the purpose of the I is that this I is actually a variable you can use. And the value that it takes is actually based on range. And the range goes from, if you input to 10, it goes from 0 to 9. So that's 10 numbers, but it starts at 0. Instead of going from 1 to 10, it goes from 0 to 9, which is 10 numbers. So I in range 10 would print the numbers 0 through 9 if you try to print I, because that's what I takes the value of 0 first, and then on the second loop, it takes the value of, on the second loop, it takes the value of 1, and on the third loop, it takes the value of 2, and the next one is the value of 3, and then it'll, for that range of numbers is what it's the value that it takes up. So if we try to run this, oh, I didn't scroll, but yeah, you can see that first I took the first print I was 0, the second print I was 2, or sorry, I was 1, and the third one was I was 2, the fourth one was I was 3, and then so on. It's 10 numbers that goes from 0 to 9. That's what range is. So that's a basic for loop. Oh yeah, the range, you can also play around with range in different ways. Let's say, for example, you wanted it to go from, start at 5 and go to 10. This would actually go from not 5 to 10, 5 to 9, starting at 5. So I would take the range of 5, 6, 7, 8, 9. So 5 numbers. Print this. Yeah, 5, 6, 7, 8, 9. Starts at 5, ends at 10 minus 1. Yeah, and then also you can add a third parameter, which you can say I want to increase this to 20. This parameter or this argument is how much the for loop increments by. So before, the for loop was always incrementing by 1 by default, but if you want to increment more or less, you can specify it here. It has to be an integer, I believe. Try to float. Okay, yeah, it must be an integer. So we can do 2, for example. So it'll start at 5, then go to 7, 9, 11, 13, 15, 17, and then 19, and then, yeah, I think 19 would be the last one. Yeah. So it goes 5, increments by 2, increments by 2, increments by 2, until the condition, or until it reaches 20 minus 1. So then stops. So yeah, and then you can also have it increment downwards. You start at 20. What's how you do it? 25, yeah. So you can increment it by -2. Start at 20 until it goes to 5. In this case, yeah, because if you increment it by 2, it'd be greater than 5 minus 1. Or I think, okay, yeah, it's closer, it's in between it. So it'd be 6. And then you can also, and yeah, so this presents the issue that if you do like 5, 20, and you do -2, this would be an infinite for loop. Okay, so actually, I'm not sure why. Okay, actually, it isn't an infinite for loop. I guess not. I guess this just doesn't run at all. It's a weird direction, but that's how it is. That's a for loop. That's the main. That's a range for loop. How it is, and there's 2 main for loops. There's the range loop, and we're gonna cover the next one. The next one is a iteration loop. So, and the iteration loop is kind of what we did here, except we didn't really know it was. But what an iteration loop is that it, instead of I taking the value of numbers in a range, I takes the value of the characters that you want to iterate through. So let's have a string here, elephant, for example. Oh, and by the way, you can change the value of I you want. It's or the name I, because it's a variable. You can name it whatever you want. I'm just gonna name this letter or character elephant. It's the same effect. For character and elephant, what this does is instead of iterating from a range from a certain number, character will take the value of E first. Then on the second loop, it'll take the value of L. On the third loop, it'll take the value of E, and so on. So if we try to print character, oh yeah, and you can see that if we just like print some random thing, hello, it should run however many letters there are in elephants at 1, 2, 3, 4, 5, 6, 7, 8. It should run 8 times. Yeah, 4, 8, yep. And if we try to print character, it should print all the characters of elephant in a listed fashion. Whoops, in character. Spelled that wrong. Here is, yeah, so you didn't see the output, but whoops. Okay, oops, it's small. Okay, let's try running this again. Yeah, so it printed the characters elephant 1 by 1. So that's an iteration loop. There's other things you can iterate through other than strings, and we'll get into that now, actually. Another thing you can iterate through a for loop is another variable type, called a list. Now, the use of a list is mainly for storing multiple values inside of one variable. So let's say you want to have a list of let's say heights of the people in your class. You can have, and the list is declared like this, surrounded by brackets, and the elements go inside the brackets. So you can have like 15, 20, 13, 14, etc. So we try to print this list. We get this. Oh, should we cut this out? So yeah, we get our list. This is our list. And now we can, yeah, you can pretty much store whatever values you want. It doesn't have to be integers, it can be strings. E, say for example, have the string E, integers. And you can store multiple values into one variable for access later. Instead of needing to have one variable for E, one variable for 20, 13, 14, you can just have all of them associated with one. And that has its uses. Mainly for a for loop, you can iterate through it. Instead of having to type out every single variable, you can just do for element in heights. And we can print element. Or you can do whatever operation you want with element. You can do addition. You can print the addition. Let's do the multiplication actually, because multiplication works with both integers and strings. Let's multiply it by 4. So So we're going to print element times 4, and this should work because strings with multiplication as well. So obviously, element takes the value of every character, or sorry, when you're working with lists, it takes the value of every entry. So element will take the value of E first as a string, and then it'll take the value of the integer 20, and then it'll take the value of integer 13 on the third loop, and then it'll take the value of 14 on the last one. So if you run this, you can see that, okay, the string E times 4 is just 4 E's. That's how string multiplication works. 20 times 4 is just 80, 13 times 4 is just 52, and 14 times 4 is 56. So yeah, you can, if you want to do an action on everything in the list, maybe you want to say this person's height is blank, for example, you can iterate through the list pretty much. Its uses, let's say for example, you want to access a certain value in the list. Let's say my height. Sam's height is equal to position 3. Oh, I also have to mention that similarly how we indexed strings, lists are indexed the same way. They're zero-based index, meaning that if you want to access the value E, you would do heights 0. That's how you access the first index. To access the second index, you do height 1, and so on. And you can see that if we try to print heights 1, it should print 20. So yeah. So let's say my height was the third index in the list. Then if you want to print Sam's height, you print heights and Sam's height. So this should get my height from the position list it's in. Let's delete this. So that's how you get theoretically my height 14. So it gets to position 3. That's how you index a list. You can use variables as indexes as well. I don't think I said that before, but yeah. Also, let's say for example your list was empty. and we want to add stuff to the heights. Let's take an input h1 equals int input what height, whoops, right, and then h2 is equal to same thing. In order to add it to a list that you already created, you use the function dot append, and specifically it's list dot append. In this case, the name of our list is heights. So heights dot append, whatever you put inside of this bracket will add to the list heights. So if I do heights dot append h1, and then I print heights, then I do heights dot append h2, and then I print heights again. What we expect is that the first time it prints heights is a list with one element, which is just h1. So it should be a list with our first input, and then heights dot append h2 should be a list of our h1 and our h2. So both of our inputs. So we have 5. What is your height? Let's say I say 13. Yes, this. Oh. Pop this out. Okay. 5. Heights. I literally spelled it wrong. Okay. Heights is equal to this. Run there. What's going on? Oh, yeah. Okay. Wait a minute. Why is it? That's odd. Why did it print the? Huh, okay, that's weird. But yeah, okay. Try that again. Asking for our height. So let's say one person's height is 12, one person's height is 13. We appended and then we printed the first time. So it appended to 12, we print 12, appended 13, we print 12, 13. And this can go on forever. You can, let's say, add stuff to the list. You can remove stuff from the list by doing this. To remove stuff from a list, there's 2 ways. To remove the last element from the, to remove, let's say you know the value of the thing you're trying to remove. So in this case, let's say it's 12 and 13. Let's remove these inputs for now. And let's say you want to remove the 12. Let's say you put the 12 in accidentally. Then to remove the 12, you do heights dot pop 12. So this will remove the 12. This will remove one 12 instead of heights. For example, if we had 2 12s, it will remove one of them. In this case, let's just have one just to make them obvious. Heights dot pop 12, which should remove 12 from the list. So if we do print heights, it should be a list with just 13. Print it. Oh, pop out of range. Sorry. Pop doesn't take the element. It doesn't take the value of the element. It actually takes the index that you're trying to remove. Apologize. That's how it works. So if you want to remove the first index, that's the 0th index, we do pop 0. So now this should print a list with just 13 in it. Yeah, that's so initially our list was 12, 13, now it's 13 because we removed the first index. If you don't specify anything for pop, it removes the last thing in the list. So it should be if we have 13, 14, 15, it should remove the 15 from the list, and it should be a list with just these 3 elements. No, 13, 14. Yeah, I removed the 15. And both these functions that we used, or I guess pop in this case, it returns a value. So similarly, how input returned a value that you could input, or sorry, that you could store into a variable. you can store the value of heights.pop, and the value that this gives you is the value that you removed. So heights.pop, this should return 15. We print it. Oh, and sorry, this. Okay, so heights.pop remove 15 and then took it at its value, and then it added that to remove, assigned it to remove, and then print remove, which is 15. So and then if we chose like an element, for example, let's say index 1, index 1 is 13, so it should take the value of 13, and it should remove 13 and take the value of 13. So 5, this is just the same thing as indexing essentially, but yeah, that's how it goes. If you want to delete a specific index, delete a, if you want to delete a specific value, the way it goes is you would use dot remove, and that let's say you want to remove the 12. This is pretty much just my initial explanation that was false for pop. It just removes the 12 from the dictionary. I think it, okay, yeah. It doesn't have any return value, so this is false. This isn't valid code. Do heights. So if we do heights, I remove 12, it should remove the 12, and we should be left with 13, 14, 15. So yeah, that works. That's how you remove a specific value. You can also index lists. You can also index a range the same way. Say heights, you say you want to do 13 to 14. If you wanted to index the first one, or sorry, the 13, it'd be index 1. If you want to reference the, if you want to stop at the 14, this is index 2, but we know that it goes from this index to the index -1. So in this case, we would do index 3. And this should be a list with just 13 and 14. That's our range. So yeah, similar to string. Another useful thing is, one last function that's useful is, if you have a string, for example, say this, just a random string. Let's say str equals str1 is equals, let's just say now my parents. A useful function to use with strings is this dot split function. So we used list dot append or pop. Is this function split works with strings. So in this case, we do str1, and what this does is the parameter that you put in, it'll split the string by whatever parameter you put inside. So in this case, it'll return that value too. So let's store that L1 list. So this returns a list of the string of split up by whatever input parameter you put. So in this case, we put space. So we're going to separate this by spaces. So list 1 should be now my parents split up by spaces. And so if we print list 1, run it, in theory, yeah, now it's this, the function string.split. Now my parents split up because of me. I mean, now my parents split up because because of the function string.split by spaces. So it's a useful thing. Maybe you want to take multiple numbers as input, space separated. You can separate them by space, and then you can have a list of those numbers. The last thing we're going to cover is another, similarly to lists, how it was how you store multiple values in a single variable. We're going to learn about dictionaries, and dictionaries store also multiple values in a single variable, but the way they're stored is every value has a key associated with it. So what that means is equals, and okay, so how lists we're using square brackets, dictionaries use curly braces. The way it works is a key is a string, and the value there is that associated with them could be anything. It could be a string, it could be an integer, it could be a float, a boolean, anything you want. It's pretty much how they're separated. I'm going to change this name to car. And the way this works is that, let's say, for example, the car is, we have a brand. So let's say the brand is Mercedes. You can have a second element where the age, I guess, of the car. Oh, this has to be a string, by the way. The keys must always be strings. Oh, not keys. Age is, say, 10, like a 2-year-old car, for example. And then let's say the color is, I don't know, color is blue. So the only difference between, well, there's two main differences. You accessed lists using indexes. You access the element in list using indexes, but you access the element in a dictionary using the keys. So what that means is if we want to get our car's brand, you would type car and then the name of the key, which is just brand. So let's print this. We're to print car brand. What this does is it looks for the key brand, and then it returns the value that it's associated with. So this should print Mercedes. Yeah. So if we put age, it should print 2, and so on. And this is just it's not really that different in terms of if you think about it, might not be different in terms of application. So it's just maybe if you want like, it's a bit easier to think about. Like if I probably wouldn't be able to have a car's information in a list, right? It wouldn't make any sense. Like I could have car and then a list, for example, Mercedes, Mercedes, then the age, and then color, but it doesn't make any sense. Like I don't know. Okay, sure. There's a Mercedes, there's 12, there's blue. I don't know how exactly to access it unless I know the exact index, like car. Like in order to access the index, it might not be obvious what car 0 is. Instead, it's more obvious that if I do car brand, I should get the car's brand. It's pretty much it makes it easier to know what the index is going to return, pretty much. And another thing is that dictionaries are unordered, meaning that one thing with lists is that the order mattered. So you could sort this list by anything. Whereas and the reason it matters is because the position of the element mattered so that you could index it. But there's no indexes. There's no positional indexes with numbers in dictionaries. So their order doesn't matter. And so you can't sort them, you could say, but you can sort lists. And yeah, that's pretty much how dictionaries work. To add to a dictionary, you would do, it's quite simple. You would do car, and let's say you want to add, let's say price to our car. Our car's price, now the key price doesn't exist. And the difference, okay, so with lists, if you, let's say we had L is equal to, say B is equal to 1, 2. If you were to reference B at 3, this index doesn't exist, by the way. If you were to reference B at 3, what happens is you would get an error because the index doesn't exist. So the difference with dictionary is that if you try to reference an quote unquote key that doesn't exist, you won't get an error. It just thinks you're trying to create a new key. So car's price, say 100, like this, 10,000. Try to print car. Let's remove this just for confusion. Let's remove this. Now our car should contain a price with 1,000. Yeah, that's how you add to a list. You reference it and then you set what it's equal to. And then to remove, you can't really remove from a list, I believe. If you can reassign the values, but I think, oh yeah, sorry, you can delete value from a list. I think it's Cardell price. Sorry, let me just. I believe this is how you do that. Okay. Oh, sorry. It's Del Car price. I think. Nope. Okay. I actually. Oh. Sorry, this should work. We are okay. We are actually over time. Yeah, that's how you delete the delete a key. Sorry. Yeah, this is how you delete a key. Delete the element from dictionary, use the del function. And yeah, and if you to reassign, you just call the key and you set the value. And one thing I missed for lists, I apologize, is reassigning. Quite simply, if you have say heights and you want to, let's just change 15 to 0. You just reference the index. In this case, 3 is equal to 0. Heights, and we should get, yeah, we should get a list of 13, 14, 0. And that is it for lists and dictionaries, and that is also it for Python 2. That is it for this module. No problem, Albert. Unless you have any questions, you are free to go. There is a practice problem that involves the stuff we learned in Python 2 and Python 1. Give it a go if you want. If you're able to solve it, then probably means that you were able to understand the concepts thoroughly. I'll be taking it up, the solution, in Python 3. But other than that, you guys are free to go for the activity and the break. No problem.